Okay, so you can take all of the index laws, and as well as them being with numbers, you can also apply them to algebraic things as well. So just want to quickly recap that you can apply all of the stuff we've done before. As long as they have the same base, you can do the same things with the numbers as bases. So this one is the multiplication, where you add the powers, so you would just get x to the power of 6. This one is division, where you subtract the powers, and 5 take away 7 is minus 2. Here you multiply the powers together, so you get 3 times 4, which is 12. If you have a negative power, you write 1 over the thing, but with the same with the positive power instead. And anything to the power of 0 is equal to 1, unless this thing here, b, was 0, because we don't know what 0 to the power of 0 is. I guess with this y to the minus 2, you could also write that as 1 over y squared as well. So all of these things are going to apply to algebra as long as they have matching bases to each other. Now I want to quickly work out what happens when we take a particular expression and we raise it to a power. And we're going to think about what happens with these two calculations and see what the differences are. So we've got 3 times 4 squared. Well, there's two ways of thinking about this. One of the ways of thinking about this is I could just do 12 squared, which is 144. Or I'm going to see what happens if I decided that I could do the squared to the 3 and the squared to the 4. So I have 3 squared times 4 squared, which is 9 times 16, and let's see if 9 times 16, yep, it also gives us 144, so that's pretty good. It seems to tell us that if you have the power up here, you can put the power on either side. Well, would that be the same if there was a plus in the middle? So let's work this out in two ways and see if it works. So 3 plus 4 squared, that is 7 squared, and 7 squared is 49. Now, if we put the power inside both of them, we would have 3 squared plus 4 squared, which is 9 plus 16, and 9 plus 16 is 25. Uh-oh, these things do not match. So you cannot take the power when it's being added in the middle. You cannot say that it is 3 squared plus 4 squared. That does not work. This symbol here means that it does not equal. Whereas for this one that we've got here, it actually does equal what you might expect. It is 3 squared multiplied by 4 squared. So that power on the outside applies to both of things on the inside, but only if it's multiplying. If it's adding, it doesn't work. And you can see with numbers it doesn't work, but it does work with these numbers over here. So the power law applies to each term of a product, but not a sum. This is a product, so it applies to each term. This is a sum, meaning adding. It does not apply to each term. You'd have to do something different for this. So what this means is that if you have a, b, c to the power of n, you would have a to the power of n multiplied by b to the power of n multiplied by c to the power of n, which you might just write as an, bn, cn, a to the power of n, b to the power of n, c to the power of n, because we don't really use multiplication symbols with algebra. So I'm going to do these 4 examples, and then you've got these that you can have a go at here, and then we're going to do some stuff with multiplication and division. So this power of 3 is going to apply to each of these terms. So we're going to have a 3 cubed, then we're going to be doing a squared cubed. Now this is kind of like a brackets law, right? So you're going to take the 2 and the 3 and multiply them to get the power of 6. And then you get the 3 and the 3 and multiply them and get the power of 9. So what we need to do is 3 cubed, and 3 times 3 times 3 is 27. So it's 27, a to the power of 6, b to the power of 9. This squared is going to apply to each of these parts separately. So we're going to have a 4 squared, we have x squared squared, we have y to the power of 4 squared. That might explain a little bit more clearly why we multiplied the powers. You get the 2 times the 2 and the 4 times the 2. 4 squared is 16. You're going to then multiply those 2 and 2 to get x to the power of 4, and you multiply the 4 and the 2 to get to the power of 8. Now you can have negative powers as well, so we're going to have 2 to the power of negative 1. I'm not going to do this whole brackets bit, we're just going to see how that number can multiply with this. 2 times minus 1 is minus 2, so that's a to the power of minus 2. We then have b to the power of minus 3 and then a power of minus 1, and minus 3 times minus 1 is going to just be 3, and then we have c to the power of minus 4. 2 to the power of minus 1 is just 1 over 2, so it's 1 over 2, a to the minus 2, b cubed, c to the minus 4. Now in the next video, I'm going to talk about how you can simplify this or write this in a different way, but for now we're just going to leave it in this particular form. And then the last one, I've got a 3 to the power of minus 2. I'm then going to do the x to the power of 4 to the power of minus 2. So you multiply the 4 and the minus 2 and you get minus 8. And then you're going to multiply the minus 2 and the minus 2 for the y. And the negative times the negative gives you a positive 4. So 3 to the power of minus 2, that's 1 over 3 squared, which is 1 over 9. So it's 1 over 9, x to the minus 8, y to the 4. And like I just said here, in the next video we're going to learn how to write these things in a slightly different way, but for now I'm kind of happy to leave them. So I want you to have a go at these 3 questions that say your turn and see if you get the same answer as me after you watch me go through them. So this first one is just going to be 2 cubed multiplied by x cubed, because there's like a power of 1 there, it isn't there, it's just an x to the power of 1 and 3, and then we get the 2 times 3 for the y, which is 6. Now 2 cubed is 8, so it is 8x cubed y to the power of 6. We've now got a 3 to the power of 4, a squared to the power of 4 is a to the power of 8 because they multiply, and then b to the power of 12. 3 to the power of 4, that's 3 times 3 times 3 times 3, which is 9 times 9, or 81. So it's 81 a to the 8, b to the 12. Now for this last one we have 10 to the power of minus 2. You're having a negative 2 times negative 2 for the x, which gives you a positive 4, and the negative 3 times the negative 2 for the y gives you a positive 6. So all we need to do is just quickly work out what 10 to the minus 2 is. Well, it would be 1 over 10 squared, which is 1 over 100. So it's 1 over 100, x to the 4, y to the 6. Okay, so in the next video, we're going to investigate multiplication and division, and we're also going to break down how we could rewrite things like this and this in a slightly different way. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.